Hello, in this video I'm going to explain how dimensions influence on geometric thinking and why Pythagoras theorem works in two dimensions and what kind of formula we should apply for cubes. For linear thinking, it's enough to have 2 points and line between them. It doesn't matter what kind of unit of measurement we are going to choose, meters, centimeters, inches or any other. To double the line, we will need twice more distance between the points. However, if we will use the same method for the square, we will get 4 times more space. It happens because we have doubled not only the length but also the height of the square. But if we need twice more space than original square, we have to divide 4 times larger square into 2. That's why it's very simple to use diagonal line inside the big square, which will divide all 4 little squares into the half. Anytime, if we need to double the space, it's enough to use diagonal lines on top of the square. And if we will use any decimal unit for the measurement, original square length will be rational number, but double space square length will be irrational number or vice versa. Also, for any decimal unit, it's important to keep the same unit of measurement to not confuse what is the total space of the square. For example, 1 centimeter length and height square is multiplied 1 to 1 and equals to 1 square centimeter. But at the same time, it also 10 millimeters length and height square, which is 100 square millimeters, which is 10 times more than 1 centimeter. But we have to keep in the mind that measuring unit is relative to the space. For 1 square centimeter object, it's just 1 square, but for object with 1 square millimeter length, it's 10 times more space to cover the same area. Now let's get back to doubling of the space. This is very well known Pythagoras theorem, which states that hypotenuse space is equal to sum of the leg space. And for this case, we can also use same square model to describe the regularity behind the theorem. As we remember, the difference between linear thinking and geometric progression was influenced by a number of dimensions, and same applies to cubes. Same Pythagoras theorem doesn't apply to cubes, as on surface of the cube regularity remains the same in the equation, but in depth, as hypotenuse is longer than legs and they are not cross diagonally with each other in third dimension, it creates additional depth, which gives another equation than Pythagoras theorem. Thank you for watching this video, and if you liked it, don't forget to share with your friends, and also you can check the link to my book down below.